thanks for whoever provides the synthesis question. We're going to see how we're going to approach this one. It's not the correct answer of this one doesn't matter. It's how you start to think that would really matter in this case. Are you good? All right. I'll use a different color for thought. Different color, let's say color blue for what's in my mind. And then we will write the forward synthesis after this. It's more or less like, how should I chalk stuff off? Okay, the first stuff I can chalk off is this one, right? Because it's ether, but now we most likely to do reaction on alcohol. Like, look, there are a lot of more bond forming in this case. So I can chalk this one off, and once this one is being chalked off, okay, it's become here, right? That's the reaction we learned today, which is ether formation, right? Okay, so this way is it's just like a, okay, let me still write H3O plus. This is just like the protecting group. This is the how we put protecting group in today's notes, but this is also the last step of the ether. Are you confused? The last reaction of today's notes.
Yeah, I get that. I was just gonna ask, how did the whole bond move from the tertiary one to the secondary one?
Whole bond?
Like the entire line attached to the circle.
This one?
Yeah, you moved it to that other one.
Oh, okay. Sorry. That's a typo. Oh, yeah. Okay, that's a typo. Okay. Are we good with methyl is this CH3? Is how, are we good with this? You look confused? This one. It's, okay, this is the ether. So if you are confused with this part, it's note 24, front page. Last reaction. Okay. Are we good? Because we just learned this today, so people, it's okay if people are confused, but I'll put which note it is. So, all right. Here, okay, it's the same game of alcohol. And we look what we have here, there's a bond. It's carbon-carbon bond. That's the new formation, right? We will do the right route first, and then I will explain on which side we can chalk them off. Okay, okay. So in this case, we should start to think about how can we treat the whole group as a R group, and bond to something just next to oxygen. A good thing of here, okay, how to use Grignard is look at if there's a bond, carbon-carbon, okay, carbon-carbon bond formation. Okay, if you see this, and then you also see right after this carbon-carbon bond formation, one of the carbon is bound to hydroxyl group. That's a really strong hint to say, okay, we're good to use Grignard in this case because we will form the hydroxyl group in the correct position. And in this case, you will need to treat this whole part as a large R, okay? And that way, okay, become H, okay, O. And our whole R group is minus mgx, right?
So it's where it's coming from.
Yeah. It's forming this.
Okay.
You don't need to show mechanism in synthesis. You only show reagents.
Mm-hmm.
But I'm just showing, okay, you can attack here, right? That's where this orange bond is formed. Are you confused? I can write, but I will erase the I can write with red, but I will erase this, okay? Because in synthesis, you attack here, then you form this bond, and form the hydroxyl in the second step. Okay, so this is step 1. Okay, step 1. Step 2 is H3O plus. In step 1, you only form O minus. In second step, you form that hydroxyl group. Are we good? Okay. But I will need to remove the arrow because it's not a mechanism question. It's a synthesis. In synthesis, you only write the reagent. It's kind of like a synthesis is your procedure for whoever will do this reaction. So you should not show arrow pushing. Okay. Are you good? Okay. All right. So we are now in. Okay, we're now in here. From here to here. It's just like very close, right? It's very close. Looks like this was RMGX, so there was an X. Or if you use RLI, it would be the same. So I think it's very obvious to think this step was an X, and this step is Mg ether to form this one, right? Okay. Are we good? Okay, this step will be bromination, H mu. Right. This is the correct way of solving this. Let me pause the video.